Hello everyone, so we're back again at AP Calc AB Reviews, and this one's going to be our solids of revolution again. And this time we're going to look at an example from crackap.com in one of their practice tests that were calculator permitted. And so the question was, what is the volume of a solid that's revolved around the x-axis? And this solid, this area, this region is the parts above this function, y equals x cubed, below the line, below y equals 1, and within the bounds of 0 to 1. Okay, so basically they're asking for the volume of the region if it's forming a solid of revolution by revolving around the x-axis of everything above the curve y equals x cubed, below the line y equals 1, and in the bounds of 0 to 1. Okay, so when we draw this, again, x cubed is this. We have our y equals 1 up here. And since it's above the curve and below the line, we're just going to shade that. Okay, so this is our region. We could call it R. And we're going to revolve it around the x-axis. So if we imagine, we could get something like actually down here, this -1. Okay, so then again, we have this now. Imagine if we were rotating it, we would have this solid. Okay, so now how are we going to approach this problem? Well, there's the disk method. Again, the disk method is if you have, let's say this is an axis, the x-axis, and you're revolving something around a region like this, there's no hole. The washer, it does involve a hole. So it would be something like, let's say here's the x, we have something like this, we're revolving that, and then you see if we take a slice, we have this like donut. This involves a smaller radius, Rx, and a larger radius, big Rx. So if we do these, the disk method is pi, the bounds of a to b, Rx, this whole thing squared, dx. Then over here, the washer, the basic form is pi a b, the integral to a to b, sorry. And we're going to take Rx, that outer radius, we're going to subtract that inner radius here. That's that hole in the figure, dx. Okay, so here we could see that our solid of revolution is going to have this gap here. So we're going to be using the washer method, this example. So let's start setting it up. So we're given pi, the bounds 0 to 1. That's good. 0 to 1, that's the integral. And now we have to find our Rx and our little rx. So if we look at the picture again, I could redraw it. Let's pretend this is the x-axis. Here's 1, here's -1. Let's go a little bit. -1. Okay, so we had something like this, and I'm going to revolve it around this. So then we spin that thing around. We're going to have something like this. There's that gap in between. Okay, so now we know that it goes to the upper line y equals 1, so that's going to be our Rx. Rx is going to be 1 squared. Now how about our little radius? So if we had this, here's 1, so we found this Rx. So what's this? What's this other area right here? Well, it's going to be the graph of x cubed. So we're going to just minus x cubed. We're going to also square it. And dx. Could do some simplifying here. You could just write over here pi 0 to 1, integral 0 to 1, 1 minus 3 times 2, x6 dx. Now we just do the FB minus FA. That's the fundamental theorem of calculus. We do some simplifying as well. So now we get pi times x minus x7 over 7. Again, this is the power rule doing integrals. This one becomes an x. This x6, you bring this, you add 1, so it would be x7, and you divide it by n plus 1. I'm sorry about that. You divide it by n plus 1. So we get x minus x to 7th for 7th. And we're going to do it to 0 to 1. This becomes pi times, remember it's FB minus FA. So we're going to get, so this is 0. We know our FA is going to be 0 because there's x's everywhere. Move this over. So now we just need to worry about our FB, and we're going to get 1 minus 1/7. And that's going to equal 6 pi over 7. And that's going to be units cubed, because it's volume. Right, so now go back to our practice test here. And I think this was a different one. Okay, so practice test, we would look for this option, and that's our answer. Please reach out and research more if you have any trouble with solids of revolution or anything with calculus, math, any of your classes. You could always reach out to someone. There's always going to be people willing to help you guys, and your pursuit of knowledge is going to help you through life. And take care and do something nice for someone. Bye.